Friends, before we go ahead and start creating new tables and modifying existing tables to enable compression and work with compression dictionaries, let's go ahead and understand a few commands that will help us to gather really important information related to compression on existing tables within our database. So for that, I have included this text file, that is tab underscore compress underscore info.txt, and this file is attached in the lecture resource. You can download it and then you can bring this file to your Ubuntu machine. And when you open this file, you'll see that it has got three commands or three statements. So let's look at all these three statements and understand what information we get by running these three statements. So the first command is select tab name compression row comp mode from syscat.tables. Now this syscat.tables is a system catalog table in DB2, and it contains the metadata about all the tables inside the DB2 database. So we are going to query this table to get a table name, and we'll see whether the compression is enabled on that table or not. And then if the compression is enabled, then which type of compression is being used, whether it's adaptive or static. Then we move on to the next statement where we use a built-in admin function, that is admin.getTab compress info, and this function basically gives us some estimates on the compression details on a particular table. So we need to pass the schema name of the table and the table name, and it will give us all this information that will help us to estimate how much compression are we going to gain by using adaptive compression or static compression. So we'll use this statement as well. And then this last statement, this lengthy statement, basically gives us the actual table size in KBs, in MBs, as well as in gigabytes. So let's start with the first statement, and I go to my terminal. And before we execute this statement as is, let me execute this statement that says describe table syscat.tables. So I'm going to look at the structure of the system catalog tables. So I see that 85 records are returned, and basically this system catalog table that contains metadata about all the tables in the sample database has all these different columns. For example, it will have a column for each and every table name. It will have the column for schema in which they are residing, the type, whether it's a table or a view, a lot of other information. But we have to look out for table name column, then row comp mode. So if I scroll down a bit, I'll be able to see that there is this row comp mode column that basically tells us which type of compression is used on a particular table if it is enabled. And this compression column will contain the information related to whether compression is enabled on a table or not. So now let me just clear the screen, and this time let me execute this statement that says select tab name comma compression comma row comp mode from syscat.tables. So this will bring up the information about all these tables that are there, that is 482 as of now. So all the table names are there under this column, and whether compression is enabled are under this column. The third column is empty because no compression is enabled on any of these tables, and you can see it is not very well formatted. So what I can do is just to format it, since the tab name column is 128 characters in length, so that's why it's occupying so much space on the screen. So I'm going to trim that by using the substr function. So I'm going to say tab name comma 1 comma let's say 10 as tab name, and then rest of the command remains the same. So I'm going to trim the tab name column, and it is going to start with 1 and it will terminate at the 10th position, and this will name the new column as tab name column. Hit enter, and here it is beautifully formatted now. So you can see that the compression column contains n, that signifies that no compression is enabled on these tables, and if no compression is enabled, then the row comp mode would not signify anything, so it won't display static or adaptive compression types. Now you can modify the statement even more if I want to look at the details about a particular table only. So I'm going to use a where clause here, and I'll say where tab name equals to, and then within single quotes you write the table name in capitals. Just make sure that you're passing the table name in capitals. So this time I'll only see the information on the employee table. So the table name is employee, compression is not enabled, and the row comp mode is blank. So the same way you can change the table name and look at the information on that table and get the information on compression and the type of compression that is enabled. Now let's move on to the next command over here. So I'm going to copy this whole statement, and I copy this whole statement. I go back to my terminal. Just make sure that you don't copy the @ sign. I'll tell you why in a bit. And I clear the screen first and I paste this command. Now you need to prefix this command with DB2, and you need to enclose this whole statement within double quotes. Just make sure you do this. And I'm going to query the details for the table employee. If you don't specify, or if you don't pass the table name and you just pass the schema name, then this will return you the details about all the tables within the schema. So make sure that you specify it, otherwise you'll have screen filled up with so much information. All right, let's hit enter. Okay, let me close this with double quotes. Let's hit enter now. Alright, so we see some details, but again this is not well formatted. So again the problem is with tab name column. So I say substr and close the bracket here, 1,10 as tab name. Let's see. Okay, it's better now. If I move to the full screen mode, I will be able to see it better. Okay, so here you have the table name as employee. The row comp mode is not there because no compression is enabled on the table employee. PCT pages saved current. So right now the percentage of pages saved is 0 because we don't have compression enabled here. If you enable static compression on this table, then you would be able to save 45% on the number of pages that are currently being used for the rows in the employee table. If you enable this table for adaptive compression, you'll save 45% on the existing pages. The average row size current is 88. The average row size static is 47. So if you do a static compression onto it, apply a static compression, then the average row size will reduce. And if you do an adaptive compression, the average row size will also be 47. So these are some statistics that will help you to kind of get an estimate about which compression method you should apply on this particular table. Now since the employee table has comparatively a very few number of records, 42, so therefore it's quite possible that the static and adaptive compression estimates are equal. But when you have tables with millions of records or even thousands of records, then you will definitely see some difference between static and adaptive compression estimates. So this is the command that will give us all of this important information. And now let's look at the last statement. So I just copied this entire statement. Make sure that you don't pick up the @ sign. I just copy this and go back to my terminal. Right click, paste. Okay, enclose this with double quotes and prefix this statement with DB2. So here we are going to query the size of the employee table in KBs, in MBs and in GB. So if I go back to my editor over here, so if you can easily understand the statement, I mean this is just trimming the tab schema to 18 characters. This is trimming the tab name to 30 characters and so on. But this is where the whole calculation stuff starts, right? So data object P size, P specifies physical. So the physical size of the data object, and the object is the table employee. Now if you have any indexes created, so the physical size of that index will also be calculated. Then if you have any long objects on this table, so the physical size for that long object. And if you have LOBs, large objects, so it will also be calculated. And then last, if you have any XML columns, so the object size for that XML column will also be calculated. So all of this when added will give you the total size in KBs. So by default, it's all in KBs. Now the second thing is the same thing. It's adding all of these different components, and then it's dividing it with 1024 so that you get the size in MB. And the third thing is again the same thing, just that it's dividing this whole thing by 1024 and again by 1024. This will give you the size in GB. So it's very simple. And let's go back here and let's hit enter. So this might take a few seconds and will give you the result. So here we get the results. So the table is employee. The size of the employee table in KB is 1024 approximately, and the total size in MB is 1, and the total size in GB is mentioned as 0. So this is how it is displayed. But when you have a table with some thousands of records, so this will go up, and then the size in GB can also be displayed. So right now it's less than 1, that's why it's displayed as 0. So no decimal points are there in the output over here. So that's it, guys. These are the 3 different statements that we'll work with. Let me clear this and I go back to my file over here and I add these substring functions so that it's useful to us when we run this again and again. So substring tab name as tab name, save, then I'll add this again. Okay, let me just pick this whole thing. So be careful while you're making these edits. Just make sure that the commas are in place and that the brackets are closed properly, and then this is fine. Okay, so another thing that I've put these @ after each of these statements just to make sure that when we run this file as a script, so this will execute all these 3 statements one after the other for us. So if you can recall, we can create scripts in DB2. It can be a simple text file, and all the statements that are mentioned in the script will be executed one after the other, so that we don't have to write these commands again and again on our terminal. So I'm going to show you a method to execute all these 3 statements one after the other. So I go back to my terminal, and if I have kept this file under my desktop, so I can see this file over here. Okay, and to execute this script, I need to prefix this with the keyword DB2 -td, and then you have to specify the termination character that is used in this file. So that is @. You can even use a semicolon or some other sign as well. Then you have to specify this -f or -f flag that specifies that you're going to write a file name here and along with its location. So now, since I am under the desktop, I don't need to write the full location of this file. So I just can simply write this, and if you press tab, so it will bring up this file, and then you just need to hit enter. So when you hit enter, the first statement is executed, then you have the second statement, and then we have the third statement. We get all these results. What you can do is, since we are querying for all the tables, I can add a where clause over here that says where tab name equals to, within single quotes, the table name in capitals. And whenever you have to change the table name, you can just change the table name from here within this script. And if I clear this again, let's run it. So now I am querying all the compression related details about the table employee. There we go. So that is it, guys. Let's move on to our next lecture. Thank you.